Hey everybody, and welcome back to Algebra 2 Online. So the plan for today is to start talking about graphs of sine and cosine functions, And then actually next class we'll talk about graphs of secant and cosecant. And then the one after that we'll talk about graphs of tangent and cotangent. And they really are all kind of related in those groups, like sine and cosine look very similar, secant and cosecant look very similar, and then tangent and cotangent look very similar. So it kind of makes sense to split it up into like three groups like that. So to start off, though, I just want to do another one of these kind of like mini little trig equations. So I want to find all x's in here that make this trig, okay? First thing I would do is I just move the 2 over and divide by the root 3. So really this question is saying like when is cosecant equal to 2 over root 3? But we know cosecant is the reciprocal of sine. So this is the same thing as just saying when is sine of x equal to root 3 over 2. And then really I'm just, at this point I would use like the finger trick thing. I would, I want to think for sine it's always square root of fingers below over 2. And so where do I have 3 like fingers below? Well, that would be below my pointer finger, right? And the pointer finger is like pi over 3. And so it's, 60 degrees. X equals pi over 3. But it's very easy to forget 2 very important things. Remember, you can get this over and over and over again. And also, right, if we do the all students take calc thing, right, you can get positive sine in this quadrant or this quadrant, right? So we just found basically the first quadrant, but the second quadrant one, it would basically be pi over 3 and then another pi over 3. And then, this in here is pi over 3. But this is the angle that would be the one in the second quadrant. And that angle is 2 pi over 3, right? Just 120 degrees. And again, don't forget that you need multiples of 2 pi because you could get to that and then you could go around and around and around and around and around and around and around again. So that was it in terms of solving it. Down here, I have a little picture actually that can kind of show why this is the solution. All right, so this green graph is actually what cosecant looks like. All right? We will graph it soon. You'll see why we get that. It's kind of weird looking. There's actually asymptotes on secant and cosecant, and also actually tangent and cotangent. There's asymptotes in here. And there's asymptotes actually for the exact same reason rational functions have asymptotes. So we'll talk about that. So that's my cosecant graph, right? And then this horizontal line, this purple line right here, is actually the line 2 over root 3. And so really I'm just setting up this equation, right, in a picture. So the question was, when is cosecant equal to 2 over root 3, right? This is going to be more clear. This is y equals 2 over root 3. And you can see the intersection points, right? And it's probably a little hard to see, but this is pi over 3, and we found a solution. And then if you just count, so you can add or like subtract 2 pi from there, and you'll get a solution, right? So this is 1 pi over 3, 2 pi over 3, 3 pi over 3, so that's 1 pi over 3, 2 pi over 3, 3 pi over 3. So that right there is like 2 pi, right? And we found another solution. And you could just keep doing this. 1, 2, 3, 4, 5, 6. And it's kind of off, but there's like going to be another one over there. That's another 2 pi. You could go 1, 2, 3, 4, 5, 6. That's another 2 pi. And so that's another solution, right? This other one that I'm getting right here, that one is the 2 pi over 3. And again, if you go 2 pi backwards or forwards, forever and ever and ever, you're going to get more and more and more solutions. So that's kind of a picture to show you why that truly is the solution. All right. Graphs of sine and cosine. Very, very, very important functions to know how to graph. So there's actually going to be a Desmos demo thing that I give you a link to that I want you to play around with too. And it will kind of show you what I'm about to talk about a little bit better. But basically, the graph of sine and cosine comes straight out of the unit circle, right? And the really important thing to remember is in the unit circle like this, like let's just take this triangle right here. Right? Remember that, since this is a 1, the hypotenuse, right? Then, there's this y here and this x down here. And the sine of the angle in there is just y over 1. Or you can just look at it as the y value on the unit circle is sine. And then if you do the cosine, right, just based on SOHCAHTOA, x over 1 is cosine. So this is honestly all you need to remember to graph sine and cosine. As you move around the unit circle, the x value of your where you are on the unit circle is the cosine of that angle, and the y value is the sine. So there's going to be this demo that I want you to play around with where literally what it does is it kind of moves like an arrow like this around the unit circle and just plots, like for sine, it's going to always plot the y value as you move around. And you'll see as it plots it, it's going to map out sine. And then we're going to do cosine here in a second too. And as you move the arrow around the demo and you plot the x value this time, you're going to notice you get the cosine wave. So they're wave functions because as you go around the graph, right? Like for sine, we're talking y values. The y values kind of are going up here, and then they start to go down, and then the y values are negative, but now they're starting to go up again, and then they go up to here, and then they come down, and right? Like you can see that the y values are just going to go up and down and up and down and up and down, just like a wave function. And same thing with the x values, right? So when we graph sine, what I'm going to ask that you can do is literally only graph one cycle of it. So in 2 pi, right, no matter whether it's 2 pi here or 2 pi here, you're always going to get a full cycle of the wave because you would get a full cycle of the circle, right? So the way that I teach my students to graph sine and cosine is, since there's sort of 4 natural breakpoints in the circle, what I want is 4 breakpoints in one cycle of the graph, right? And the breakpoints are at 0, and like an angle of 0, this angle of pi over 2, it's probably hard to see, but that's a pi, and then 1/2 pi over 2, or 1/2 pi, sorry, and then of course 2 pi. So that corresponds to 0 angle right here, pi over 2 right there, pi right there halfway, and then 3 pi over 2 right there, and then back to 2 pi, okay? And if you just look at it, right, for sine, the y value, right here is 0, plot 0. Up here, the y value is 1, so at pi over 2, we're up at 1. For this y value, you're back to 0. So you're going 0, up to 1, back to 0. And then here, the y value, -1. And then here, the y value is back to 0, right? And then you could just keep going around. So there's no real sense in doing more than one cycle. If you can do one, that's why I write this thing down here, because symmetry is going to be your friend. Like, if you do one, then you could just like duplicate the graph further over here or go this way and just kind of keep going, right? And that's basically how we do it. So the key facts are the domain is all reals. There is no issues at all with any angle. You can take the sine of any angle you want. The range, though, right? So the range is dictated by the y values in the unit circle, and the lowest y value is -1 down here, and the biggest y value is 1 right here. So -1 to 1 is my range. There's no other possibility there. I can't get more or less than those numbers, right? And this term, it kind of got cut off, so I'm sorry about that. Actually, I can shift this, I think, just a bit. There we go. So the period is a fancy term for the cycle in the graph right here, like one full cycle of it. Basically a mountain and a valley, if you kind of think of it that way. Here's the valley, here's a mountain. So the length of time you need to get one full cycle is, in this case, 2 pi. That's the, lap on the circle, right? There's 2 pi radians, or 360 degrees. And every time you do another 2 pi, no matter where you started, whether you started here and go back to here, or here and go back to here, you should see like a full cycle, a full mountain and a valley of the graph. And last but not least, the zeros of sine are where the y values are 0. So on the x-axis right here, right, you have y values of 0. So at 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, right? You could just keep doing that. So, and also negatives, right? Like there's no reason I couldn't have thought to go negative pi, negative 2 pi, negative 3 pi, negative 4 pi, right? So it's really like a dot, dot, dot kind of situation, then negative, let's say 2 pi, negative pi, then 0 pi, 2 pi, and then dot, 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 okay? And I'm going to go through examples where I graph all these things and all this stuff. So really, once you play around with this Desmos thing too, I think the connection here between the unit circle that we studied and the graph will really make it help a lot, basically. Okay, I want to talk about the same thing now with cosine. But remember with cosine, basically, x is equal to the cosine theta, right? And so what we're really concerned with now are these x values, not the y values anymore, right? So we still get a full cycle in 2 pi, but just notice at 0, right, we're at 1, 0, 1. At pi over 2, right, you go pi over 2, you're right there, and you're at 0. So this is pi over 2, right, this is 0, this is pi, 3 pi over 2, and then 2 pi. That's my, nice cutoff points. And then pi, you're at negative 1, 3 pi over 2, you're at 0, and then 2 pi, you're back to 1, which is where you started, and then you would just kind of keep going around and around and around and around. So, really when I think of cosine, I just think of this much of the graph, right? So sine, think that. Cosine, think that one. Key facts here. Domain, all reals. We can just do it like this. Range, same thing. We can go negative 1 to 1. But the reason the negative 1 and 1 now are the x values. This negative 1 to this 1, right? Period, no difference. Full mountain and a full valley in 2 pi. The zeros are different, right? Everything's kind of shifted here. Notice the zeros are going to be, at the pi over 2 and then 3 pi over 2. And then 2 pi, plus each one of those, basically. So you're going to get a 0 at negative pi over 2, pi over 2, 3 pi over 2, da-da-da-da-da. So I'll just do these ones. Negative 3 pi over 2, pi over 2. Negative pi over 2, pi over 2, 3 pi over 2, and just like so on from there, we'll just say. So cosine is actually just, you can think of it as a shifted sine graph. It's actually shifted by this much. So you can think of it like this. This is just a horizontal shift to the right, pi over 2, right? So if you take, if you look at, I guess, this point, let's say, if you move it to the right, pi over 2, this one also over to the right, this one over the right, like you'll see that you can get this graph, and that is literally, let me make it a different color. This graph, it's not very well drawn, but that purple one right there is exactly what this is supposed to be, right? There's actually other ones that are true. You could say sine of x equals, because it's cyclic and kind of keep shifting. You could say sine of x equals cosine plus 3 pi over 2. That's another one that would work. Now you're shifting this point to the left, 3 pi over 2, which would actually also do it. Or you could shift sine to get it to equal cosine. Like if you wanted to move this peak over here just to the left, right? That would be like a plus. So if you do sine of x plus pi over 2, that would equal cosine. So maybe I'll just write that one too. So there's a lot of these I could write. There's infinitely. Oops. X plus pi over 2 would equal cosine of x also. So they really are just very, very similar shapes. They're just shifts of each other. And it kind of makes sense because, in cosine, we're thinking about the x values. And in sine, we're thinking about the y values. And so they're off by just, pi over 2. Like, if you want to, think of it, it's like the y value of 0 happens pi over 2 over here. That's kind of how I think of it, right? So you can see that the x and the y values are just off by pi over 2, really all the way around the circle, right? Everywhere. So I want to just go through a few examples now. So the first kind of thing I want to talk about is actually just some vocab before we get into graphing these. And I talked about this concept, the period, already, which is really just I didn't really write the definition, but let me write it here. So it's the length, it is literally a length, like I draw in this picture, of one full cycle of the graph, okay? And so it doesn't need to be from the peak to another peak, but that's like an easy way to see it. You could, take it from here and just go to, right there. That would also be, it's not necessarily 2 pi there, but that would be, this distance is the same as this distance. And it doesn't also need to be a 0 to a 0 like that. You can go, from this point, right? And you can go, over to here, to that same point. That distance is also the period of this graph, okay? There is a nice little formula, right, that I want you to know for sine and cosine, okay? It's actually also going to be cosecant and secant, but we'll talk about that. The period, which I'm just going to write p here, is actually always equal to just 2 pi divided by b, where b is like your the number in there that acts as your horizontal stretch or compression factor. So remember, we've seen this all year. This number is always backwards. Like if it's 1/2, you would think it maybe horizontally compresses it, but it actually stretches it. And if it's like 4 in there, you would think it would actually horizontally stretch it, but it actually compresses it. So this is a very important little formula in a sense to know. This will always calculate your period for you. This term is another important just vocab word, and it is defined really as just the distance off the midline, which is pretty intuitive concept. There's like a middle line to these waves, right? They're symmetric, like above and below a line in a sense like that, like the same distance above and below. And the amplitude is just the distance from that middle point, like where your zeros are kind of, right? Up and down from there. That's the amplitude. And nice thing is that the amplitude is actually just always just A. It's just like A, if you have A f of x, it's just your vertical stretch or compression. And so you don't actually need to do much work there. You basically can look at what A is, and that's just the amount you move up or down, like you stretch up or down. So those are just two words that I'll kind of say commonly, and I want you to know. So let's do a few examples. So this first one is just 2 sine of x over 4. And personally, the thing I like to do first is find the period, because that's going to dictate actually how I mark off my graph and stuff in here. So I'm just going to do 2 pi over b. b is a quarter, right? And so if I do 2 pi over a quarter, I would just get 8 pi, right? So in one cycle, I get 8 pi, right? And so everything should just be split up into quarters for whatever your length is, right? And that just comes from, the unit circle. There's these nice natural quarter breaks like this. So if I want to split 8 pi up into quarters, half of 8 is 4, half of 4 is 2, and so this would actually just have to be 6, right? So that's how I would mark off my x-axis. And then the amplitude, in this case, is 2, which is literally that a value. And there's no plus or minus numbers in this equation, so there's no shifts, right, at all. So this one, literally, the 2 is just going to represent how high off the middle you go. So I kind of cap it off at 2 and then -2. And then you can it's a sine, and so you kind of just go back to this picture, and you need that general shape. And so we kind of think, well, sine of 0 is 0 in the unit circle, and then the shape that it does is it goes up there, and then back down, and then back down, and then there. And those points I just marked off are truly just following the unit circle, right? The y value on the unit circle. So 0, 1, 0, -1, 0. Just to highlight that. 0, 1, 0, -1. And then you can just connect it with a curve. That's it. And it's good to put arrows because it does just keep going like that forever. So that is literally all you got to do to graph that one. For this one, cosine, same kind of stuff. The one thing that's a little different here is we got some negatives, but they're no different than anything we've seen all year. These just represent, this one represents a horizontal flip, and this is a vertical flip. One thing I want you to see about cosine, right? So our basic cosine graph looked like, let me do that a little bit better. That, right? And it would just kind of keep going. Here it is right here, right? And one thing to notice is that cosine is symmetric with the y-axis. So if you flip it, it doesn't really do anything, right? So it's actually, if you're not getting into any shifts left or right or anything, you can basically just ignore that negative in this case. You can also just you can just work through it if it's there too, and just flip the points just to make sure that you haven't messed anything up. But here, because there's no shifts or anything, it will be symmetrical, right? But of course, if you shifted this graph to the right, then when you flip, it won't be so nice and symmetrical. Here, that's only happening because it's there's no left or right shift, okay? So I can actually just graph that one. That's fine. So now, same kind of thing as the last problem. The period is 2 pi over b. b in this case is, whoops, I just wrote 2 pi in there. There we go. B is 2, and so the period is pi. And so 1, 2, 3, 4. So this is pi, then that's my 0. This is pi over 2. half of pi over 2 would be pi over 4. And so another way you can think of this too is like once you get like what 1/4 is, you can just count by that amount, right? So if this is pi over 4, this is 2 pi over 4, or pi over 2. This is 3 pi over 4, right? 3 pi over 4, or 4 pi over 4 now, right? Or pi. So those are my x values that I would tick off. The amplitude is pi, okay? So I'm going to have pi and negative pi. And then basically now it's just the tick mark, the points like that represent the general shape. So, normal cosine, at 0 you get 1, then you're here, then you're here, then you're here, then you're here, right? That's just, based on this is like the normal kind of shape that you'd get, right? Just like that. But there's a negative, right? So everything is going to get flipped. So instead of actually this, right, you would flip like this point vertically and you'd be here. So you'd get that point. This point won't flip because it's on the line of symmetry that you're flipping. Same with this one actually too. This point would flip, right? It would pop up there. So you're going to get that point. And then this one again, flip down here. And so then you kind of can just connect it with a curve like that. So that's what you would get for that one, okay? That's all I'm looking for too. And again, I guess we should put some arrows just to kind of represent it keeps going. But these are wave functions that won't ever end. They have an infinite domain. All right. I want to do one just where we have some what I call phase shifts, so translations. They're really no different than anything else we've ever seen. Like in the most general form, this is kind of what sine and cosine can be. You can have like a plus and minus number here on the outside, plus and minus number on the inside, right? So this one just has one on the inside. And just like all year long, if you get one of these things where there's like some stuff, multiple things going in there, I would always factor it just so you can easily see what is going on, right? So if you take out pi over 4, this is your like horizontal stretch or compression factor. So let's label all that. So that's going to be your horizontal stretch or compression. This is that amplitude thing, but it's basically vertical stretch or compression. And then this is, of course, a horizontal shift 1, okay? Same thing as before. Let's do the period, 2 pi over b. In this case, it's 2 pi over 4. And if you do that out, you're going to get 8. So my x-axis would look like this. And I have an amplitude of 3. So, at the highest value, I'm going to go up to 3, and the lowest, I'm going to go negative 3. So that would tell me I should tick off my y-axis like this. And then, without a shift, right, it would look like sine would, be starting at 0, go up to 1, then down here, then here, then here, right? And we would get this kind of shape. But we have to shift everything 1 to the right because of the minus 1 in here. And so, literally I'm just going to take this point right in here and shift it over 1 to the right. Take this point here, shift it over 1 to the right. And if I do that, I'll get this. And then you can just connect it with a smooth curve. So this is what, you would get for that one. So same kind of stuff too. If I'd shifted it up and down, I would have maybe just made like a base graph, like this dotted one, and then would have shifted it, up or down from there. So really the tricky part is the period piece. It's like where you do the most calculations here. So that's kind of the basics of graphing sine and cosine.